La, 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 la. Okay, so this um tree stuff was actually not. I don't think it was that productive. So here's here's like one of the shortcomings of my approach to doing the trees. So okay, first of all, why trees? Um, why trees? I don't know. Because that's how the data is already laid out. When you I don't know, that's not really true. Okay, so I think so what was the problem to begin with? Okay, we have a state, we have a new state, and we say what is the difference between these states? Um, what is this? Well, if there's this idea that we can, I don't know, like create, or I don't know, like maybe it's like, what does it mean when these states diverge? And then I think I just thought about it as a tree for some reason. But we have like we have A, B, C, and we have this is state zero. This is the original state, and then this is a new state, state one, and then we have I don't know, like we have A, C, D, or A, C, D. Yeah. Well, in this case, it's really I don't know. Like it's hard to say. So the assumption here is that if the structure isn't the structure didn't change, only like the leaf nodes got switched out, then there's like a one-to-one correspondence of what happened. But the thing is, like, that's not really the case. But what would this look like? So, like, this would look like this. Well, DS is a new tree where we have B minus C, B minus C, and A minus A. In other words, no change occurred here because it's just zero. B minus C change occurred here, and D minus C change occurred here, meaning that we were introduced a B, and and then we subtract a C. And because we do things in a remove first, add later order, then this is actually like minus C plus B, and then this is like minus C plus D. So in other words, we remove like we just follow it left by right, left to right. So it's like oh god, did I fucking do this? I did it backwards for fuck's sake. This is A minus A. This is C minus B. This is negative B plus C. And this is because we're just like doing these this minus this. Right, so this is negative C plus D. So we delete the B object. It could be anything like a record, or it could be like a change to a setting. We could have gone from having this setting to this setting. We delete, and then for the same thing here, like this could be, it could be anything is the point. And the point is, how do we get the old state to the new state? And like an easy way to, well, basically, if you know the difference, then it encodes the operations required to make those changes. So, um, okay, but it's more complicated than this because surely it's not just a one-to-one correspondence. Like there could be, and like another thing is like the operations are not really so okay, like there is a min difference. There is a minimum difference of operations that we could do to get to the new state. So in other words, some of these depending on how we describe subtraction, like we could get much better, like much more efficient results. So like a min difference would be the ideal thing we want. Yeah, like min difference would be the ideal because we want to minimize operations to get to the latest state. So um yeah, like I honestly don't really know how to do this because it's basically it sounds like I'm creating my own algebra at this point. But basically I'm pretty sure that trees are not the way to do this. And because like another thing, right, is like how can we assume that this is A and this is C and this is D? Well, imagine we put like an element here and then this really becomes A and then this is B and then this is C and this is D. Or actually yeah. So like this becomes B, this becomes C, this becomes D. At which point like okay, like how do you even compare these things? Right? And if it's min difference, like if it's min difference, then I don't know, like I have no idea how to compare these things, to be honest with you. Just by looking at it. I mean it's pretty obvious just by looking at it, to be honest. Like so I guess if the name of the game was to put these labels where you think they're supposed to be, then like mine would go here. But maybe the computer, because it's doing it naively, would just put them right here, right? And this problem, I don't really know how to solve it. I'm not, I don't really want to solve it. Um, so I think instead what we're gonna do is, oh, first of all, I forgot to mention. So it turns out, so here's why here's like the main reason I'm moving away from trees is because like we really don't fucking need them because I mean I guess it doesn't really matter. It's just like semantics. But if so we just like how I described this problem that how do you identify these labels? Well, it turns out Cloudflare just puts an ID on everything. And I think I knew this, but I just didn't connect the dots before, which means that it actually doesn't it actually doesn't really fucking matter like what these trees look like. It doesn't matter at all. It doesn't matter. Like the point is it doesn't matter because um the goal uh the goal is to get the minimum difference between the current state, the previous state, so that we can um, perform the minimum operations required to update the state. And in the general sense, this just means okay, well if we have let's not describe it with trees because they're kind of not nice to think about. But instead of trees, we say, all right, we have space, and the goal. Okay, so we have. Here's the first state. It describes not a space. I'm sorry, maybe like a set. I don't know what you call this, but the point is, it describes a bunch of these objects. So we have like A, we have a B in here, we have a C, we have a D, we have an E. Okay, well, what about state one? Cool, well, we have
We still have our A. We don't have our B. We have our C. We have a D, and then we have like an F. So pretty much, it doesn't take. It takes a lot less thinking to just know that like yeah, we lost we lost a B, we lost an E, and we were introduced to an F. Because like this is just I don't know, it's just like a fucking you're just adding to fucking polynomials. I mean, that's basically it. So what is the difference between these states? Well that's pretty easy, right? Because like here we have A minus A, we have 0 minus B. Like okay, we don't have to say it, we have a negative B. We have C minus C. Let's put these down. We have like C minus C. We have D minus D. Jesus Christ. Then we have an F. And then we have like a negative E. And honestly, so okay, in other words, actually the inclusion of a thing is really just the same as saying we add it. Like we're adding all these things together, which really just means that this is just one big fucking polynomial. Which really means that like a better way of describing this is more or less literally just a fucking we just have like a bunch of terms and that's it. We have A plus B plus C plus D. We have and then we have like S1, which is A. What did we say? I think we had an E in here as well. Yeah. We also have right. We have A plus C. Just say it like this. Plus C plus D plus F. Okay, well ds is just S1 minus S, which is literally just this shit minus this shit. So we have A minus A um, plus just minus B plus C minus C plus D minus D plus R minus E plus F, which is just like this is just negative A plus A. This is and then minus B minus C plus C minus D plus D minus E plus F. And then now, like, we just read this left to right. Well, we delete A, we add. Oh no, we. So I think we just combine. No, we just combine like terms. So I'm sorry, like we just don't need this. We don't need this. We don't need this. This just becomes delete a B, delete an E, add an F. Right. So this could be like a record. This could be a setting. This could be like what would that be? How do we just wait? Yeah, how are settings described? Because you can't delete settings. Um, Okay. This I think this just describes the old. Oh yeah, yeah, yeah. Okay, okay. So this describes the old state. So this describes the old. Okay, so if imagine if E and F describe like the same setting, like from going on, like on to off, for example, like where E, let's just say E is on. Let's just say like E is like on, and F is off. And we basically went from, well, we did negative E plus F, which really just means um, negative on plus off, which really just means um, it. So if we're like flipping a switch, it actually doesn't really matter what the previous state is. All it matters is that we just change it to the latest state. We just flip the switch off no matter what. So I think with settings, because they describe they describe like overriding an existing thing. Whereas like records, for example, are describing like a quantity of records, and like some of those records could actually be deleted and added and rearranged and stuff, but that's not really the case with settings, or yeah, with settings. So I don't think it. Yeah, I think it would. I'm not so sure, but that's how I think it works. So basically, yeah, yeah, yeah. So this could be a record. Oh, then okay. Well, that's if that's the case, then how do we hash settings? How do we identify settings like objectively? Okay, well, how do we identify anything objectively? How do we identify? So, okay, the thing is, Cloudflare, everything in Cloudflare has an identifier, but here's like another issue. Is here's an issue, right? Is what do these things describe? What do these things describe? Right. So let's just like objectively speaking, let's say like we have a record. Let's just say, for example, we have a record, and we have like I'm just trying to think. What is like a tangible example that we could use? Like, I guess we have a record. So, we have like a C name. No, 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 no. We have, okay, well, let's just say we have like a light switch, which is on, and we have a light switch, which is off. And like these both have their own labels, right? So this is A. This could be A. This could be B. And the new state is also described by, well, let's see, like let's just say let's assume that like order doesn't really fucking mean anything. Order doesn't really mean anything. So like for example, this could be A, and we could have turned it off. So we turned off A, and then like let's just say for example, this is C, and this is on, for example. Well, if we describe DS, the difference in states, then it's very clear now that these have an objective there's an objective understanding of what objects we're referring to. Like there is multiple lights because they have their own identifiers, and this might not have been a good example because I don't think it ties in with the records. But okay, well the point is they have their own identifier, and you know what are the things we can do with these lights? We can turn them on or off. So okay, like what is happening to light B? Well, in the new state, we don't even have a light B, which means that what is the thing we're trying to describe? I don't know. Well, if we talk about the difference in state, we could say like A, for example, A goes from on to off. Jesus Christ, I'm so bad at drawing. And then right to off. And what else? Like C. Like what happens to C, right? C just goes to on from what? I have no idea. And like what happens to B? B goes from off to what? Like I don't really know what this means, to be honest. So like I don't know, what does that mean? Does that mean that we went from nothing to something? Somehow we just introduced a magic C with an on state. Yeah, so we just introduce a new thing, and like in this case, we just get rid of something. So yeah, like I guess this is like delete. Like this is just delete. This is like delete B. This is like create C. This is change A, right, from on off. Should we just say this on to off? This is create C on. Whoops. No, it's not the same. This is create C on, create B off. Um, yeah. So, what are the unique identifiers for these things? Well, they are Cloudflare IDs, and for the case of things that don't have IDs, do they all have IDs? Well, let's take a look at the data real quick. Let's take a look at some of this data. So, oh my God, this is awful. I don't know why I did this polynomial shit. It's so fucking bad. Like it doesn't even make sense. We're using it. Everything is just 1 degree. It's completely linear, and we made a polynomial class even though we're only expressing linear terms, and it doesn't make any sense. Like it doesn't make any sense that we call this. If anything, it should have been, I don't know, like this idea of just grouping, oh, common terms. I don't know. Yeah, I'm not sure, but anyways, mistakes happen. So Oh my god, this is terribly slow. Sublime is so slow. Like, why does it take that long to fucking regex? It's only... How many characters is this? It's only fucking 686,000 characters. Okay, so... Yeah, so if we take a look at settings. So, yeah, I mean, they do have an identifier. They do have an identifier. But they're not global identifiers. Because they depend on the zone because each zone has these settings attributes. So do we need a stateless thing that just it takes an ID and it changes it and it just changes it. Like it just takes an ID and it changes it. Yeah, I think that's the way it should be done. And we shouldn't need to know about the parent or the zones or any of that. Like everything should just be in just stateless. So, okay, what does this mean then? Well, I mean, honestly, the is the tree approach. Why was the tree approach bad again? Well, one, it's really hard to work with. Two, oh yeah, it assumes. Yeah, it doesn't take into account the IDs, but that's not really. It doesn't really matter if it's a tree or not. But I don't really want to. I don't want to do trees anymore. Like it's just unnecessarily complicated. And I think that if we have IDs and things can be changed statelessly, then that's the route to go. Just like have stateless, um, just have some big like ref list that you iterate through and compile these changes. And yeah, so I'm just going to put this in another file for now. And we're going to oh, so here's the other thing I meant to talk about. So, do we need to hash these objects to make them objective? Okay, so because here's the problem, right? Is Cloudflare. Okay, this only applies assuming. Okay, this is Cloudflare. This is us. We're creating the state. And we don't know anything internally about how Cloudflare compiles their IDs. So that means that we cannot actually re-replicate the IDs. And if we can't re-replicate the IDs, then this really just means like this. And in which case, these are going to get deleted no matter what. And this is going to just create a bunch of stuff, right? Because we don't know. We don't actually know how to define A. We know all we know is that Cloudflare does it, and we don't know how to. We don't know how to get A. No, we don't know how to get A, B, C. We don't know how to get any of these. So we have to figure out how do we get these. And I think a solution is to
encode, I don't know, just encode the setting, like hash the settings that we care about or something. We just have like an encode and decode function. Like I don't know, we just have encode and decode. And yeah, like that's it. Encode, decode, encode setting, decode setting. And yeah. So yeah. We need some mutual description of how these things are. We just want some like mutual description. And it's I feel like it'd be easier to get that description if we ignored the attributes that we don't care about, and then we only hash the things that we do care about. Yeah, I'm actually not so sure, but I mean that sounds right to me. So here's what we're gonna do. Um, First of all, let's make sure that we don't need to depend on parenting, because if we do, then the tree structure might be somewhat useful for us. And but I don't think we do. So if we take a look at the old code, which deletes records and creates records and all this stuff, like it looks like to me that it's all look it like to delete a record, you literally just you give it a record. You don't have to give it a zone. You don't have to give it anything regarding anything but the record itself. It's completely independent of anything else. So, um, same thing with not with routes. That is not the case with routes, but um, that's fine because we can actually encode. We can actually encode the state, the zone ID and name into the route. So I'm not actually worried about that. Um, you know what? Actually, now I'm thinking about it, it actually doesn't even matter at all because we could just encode. We could have encoded that shit from the beginning, which means that we didn't really need a tree from the beginning. So yeah, we're not gonna do this tree. We're not doing this tree shit. We're getting rid of all of it. We're getting rid of all this tree bullshit. So yeah, we're getting rid of it. So bye bye. But before we do, just want to make sure that yeah, we don't need this crap. Yeah, man, that was awful. I'm so glad we are not working with that shit. And then, yeah, we don't need this shit. And then, 1 sec.
Okay. So, all right. So basically, where was I? Yeah. So the issue with the problem is like, how do we identify these things, right? Because the reality is, if we cannot replicate the IDs, then these are just this is just mumbo jumbo. We don't know what it is. Essentially, this just becomes f of x. It just becomes f. So we have no idea, and we don't want that. So we want to instead these are not going to be hashes. These are not going to be IDs. They're going to be hashes. And in order to get those hashes, well, we can make a function that just encodes these, that just hashes these things. Like this would be what? This would be no, I don't actually think hashes are good. I think we should just decode and encode. We decode it. Um, yeah, we just decode it. We decode it. Then when we encode, or I don't know, we decode it, and it just creates. Yeah, we just need to do like some object, and basically we will. Yeah, we're just gonna have a decode function. That's it. We just decode these things. So real quick, what does dispute do? I don't know why I called it this, but it pushes the differences to the network. So we describe the difference between the state and the new state, and then which looks like um, which looks like this, right? This describes the difference between new state and old state, or like this basically. And we run through the changes, and obviously we don't actually need to um, we don't need to like re we don't need to reduce this. We literally just like if we're doing this in real time, where we accumulate this state. Okay, we get this state, we build this state, and then as soon as the subtraction operation happens, because I don't think there are going to be any more than one. Like there's never going to be any more than one of the same term subtracting from another. So we're never going to have like we're never going to have negative 2a plus a. It's always just going to be an a followed by maybe or maybe not followed by another a. So you're never going to have more than one create or deletion operation happening in succession. So, and if I think like if that's the case, whether or not that's the case, actually. Um, we really just need to um, well, if we subtract these things, this is like saying, okay, well, A exists. Like, okay, we've defined this. Okay, well, we subtract A, means we can delete A. Okay, well, this minus A is described by the initial state, and this state 1 is described by the new state. Well, what if as we're iterating through, okay, what if every time we create something, it goes into like a refs list. We just have like a refs list, and like we just put A in it, or I don't know, like we just put A in refs. So we have refs, and just like imagine we're going through this thing. Okay, we have A in the initial state because we decoded an A, and then we have a B, and we have a C, and we have a D, and we have an E. At which point we know that given this, we just know that well, what do we know? We know that anything that is in S, which exists in S1, well, let's see. A minus A, nothing happens here. A deletion happens here. So anything which is in S, which does not exist in S1, is going to be deleted. So what is that? That's S and not S1. We just delete all of S and not S1. And right, because well here's S1, here's S1, here's S. This describes the difference. And these are the things we create. These are the things we delete. These are the things we change. These are the things we like change. Right? So yeah. So the things we delete is S and not S1. And the things we add is just S1, not S. Yeah. And the things we create is S1 and not S. So, as I was saying here, like this can be done as soon as an entry is put in here. So every time we create an entry in this list, we can actually compute like we can do this check, and we can just do it right away, I think. And the reason for that is because I don't actually know how to describe why that's the case. Because, well, is it because these are separated by addition and multiplication? Yeah, I don't know. I don't know, but we can append these and just delete in real time. Say, hey, if E, we do this check, hey, if E exists. No, maybe that's not the case. I don't actually know if we need this refs thing, but basically, we just do this check every time. And oh yeah, so we have like two refs. We say, okay, there is it doesn't matter. Like it really doesn't matter to be honest. We can calculate this brute force every time. And we say, okay, every time we create every time we discover a term, every time we decode an object, yeah, like every time we decode an object, we just run this. So every time we decode, then we run this and this, right? I think we actually have to be careful. I think we have to do create after the fact, actually. I'm not sure, but I think we'll figure it out. So we calculate these differences. And I don't actually think we even need it. Shit. What if it's like ds dot first or something? What if it was? What if this was it? I think this is it. I think this is it. We get the differences and then we push the differences. Yeah. So, all right. Well, now we need a data structure to describe this. So, well, S and S1 have to be said data structure. It's I don't know what to call it yet. I'm just gonna call it like space, and then we can create the space. We can and then we're just gonna subtract spaces. And like our space can have items in it, described by a dictionary because we're just going to be looking up. We're just going to be using the lookup, and we're going to have um, right. So we can have items in the space, and you can like subtract spaces, and it will. It's just going to compute the overlap for each item. And items, and then like so there is a there's like a coefficient for each item. So okay, actually, here's all it is. It's like a polynomial. You can add and subtract polynomials, it, except everything is 1 degree, and there is no x term. It's just there's no x. It's just this like a plus b plus c. It's like this, and like no, that's it. That's all that a space is, I guess. So yeah, and yeah. I mean that's it. That's literally it. So if when we subtract two things, then we have to fucking I don't know. Does Python hash based on memory or based on value? Does Python hash memory or value? Does Python hash memory value? I don't know what you call this. Yeah. Python hashes the value. So in which case, we don't even have to compute a checksum or anything. We just have to have a mutual like medium to describe the um, the Cloudflare and local states, which basically describes a decoder and like no, that's it. It just describes a decoder. So we decode this to get the mutual state. So we have to get a decode function. Real quick, there was actually some useful code that I deleted. Yeah, I needed this code. Yeah. Yeah. So yeah. So the idea is when we're pulling all the data from the server, then we just we get state. Yeah, we get all the page rules, the records, the rules, etc. This right here is basically decoding, but we're gonna have our own decode function. So we're gonna have def decode, um, and it just decodes whatever arbitrarily. Page rules, records, yeah, or page rule and page rules, record, rule setting,
and we just decode each of these things. What? Oh my God. And yeah, so and we just handle all this in here. We call this a structure. Oh fuck. Yeah, I don't even know if this is worth it anymore, but it's fine. Now we don't need these, and state. Another thing is this is going to be described in here. Pages and zones, these do not need to be global variables. We don't need any global variables. Um yeah, yeah. And then down here, oh god, did we fucking delete that code? Oh shit. Oh man. We did delete it. So we have this giant disgusting decoding function which we just we put here. This decodes shit. And yeah, so we don't even need these. And then um, now this is a record. We don't need that. We don't need that. We don't need that. Um, structure. Right, at which point this is just a record. Right, so this is a record. Um, this is a setting. We're just gonna post like CFS for Cloudflare structure. Zone decode. Yeah. So, okay, setting record rule, page rule. Um, yeah. We don't do this anymore. Um, yeah, so what's the big idea? We we difference these changes, we push the changes. Okay, well, we gotta work on the space thing. All right, what else we gotta do? We gotta fucking do push. Oh my God. Yeah. Um, we don't need to keep track of zones, do we? Yeah, we do. Um, yeah, so another thing is this has to be in here. And when we decode one of these things, we need to hash the deal. Yeah, you know what? We should just honestly, we should just put all these in classes. We have a page rule, and we have a rule, and we have a record, and we have um setting And yeah. Yeah, and then, well, for the case of a record, yeah, so we need an ID. This is horrible. We have a name. We have content. We have like TTL. We have proxy. Um, we even have like zone name. We have zone ID. Why do we need zone name? Oh, like for debugging purposes, I think. And yeah, just like that, I guess. And we don't need to change anything of CFS. Um, well, this is the same as options. And yeah, you know what? Um, yeah, no, this makes sense. This makes sense. Yeah, yeah, yeah. This makes sense. And then because this is decoding, so it's supposed to do a lot of ugly shit. This just stays here. Yeah, yeah, yeah. Yeah, yeah, yeah. And then yeah, so here we care about the zone name. Oh, we forgot to declare options. So we have options, and then these are pretty much like global. These are pretty much here. And yeah, and then yeah, so like option. So yeah, options zone name, zone name, and then ID is I just set ID and value. Yeah, just value. And then we create a setting and then um yeah. And then nice. And then yeah. Yeah, we kind of do need to build a state, I think, actually, for the time being. Just because these have to, um, just have to check the, yeah, these have to check, these have to check to see if they exist. So, if state exists, self, self. Um, if we exist in the state, then that means that um well, what does it mean if we exist? Let's take a look back here. If we're already in here, well, that means we're on the right side of the subtraction. Yeah. I'm not sure.